welcome to today's video. In this video, I'm going to talk about derivatives by the first principle. So we're going to go straight into the formula. The formula for the derivatives of the first principle is given as f prime of x, which is equal to the limits of f(x) plus h minus f of x all over h as h approaches 0. So this is the formula when solving using the first principle. So we're going to take examples under this. So example, given a function f of x is equal to x squared, I have to look for the first principle. So using the formula, we're going to have, now in place where you see, now the function is x squared. So the limit of x, f of x plus h simply means wherever we see x in the function, we're going to replace this with x plus h. So we can easily write this as the f prime of x, which is equal to the limits as h approaches 0. Now in place of x, wherever we see x in the function, we're going to put x plus h. So this becomes x plus h all square minus our f first was given as x squared all into h. So right now we're going to expand this, and when we expand this, we're going to have the limits as h approaches 0. We're going to have x squared plus 2xh minus x squared, plus x squared, then minus x squared all into h. So when we collect like terms, x squared minus x squared is going to give us 0. So I'm just having 2xh plus h squared left. So we can write this as the limit as h approaches 0 to be 2xh plus h squared all into h. So we divide everything by h. So when we divide by h, we're going to have the limit as h approaches 0. When we divide h from here, we're going to have 2x left, which is this, plus when we divide h here, since it's carrying a square, so that means just one h that will be going out. We still have one more left, so we're going to have this. So now this simply means at this point, wherever we see h, now we're going to put 0 because h is approaching 0. So therefore, this is going to become 2x plus 0, which is going to give us 2x. So therefore, the f prime of x is equal to 2x. So this is the first principle. This is how you solve using the first principle. So I'm going to take another example. Take an example, given the function f of x, which is equal to x squared plus 2. So using the first principle, the formula for the first principle is given as f prime of x, which is equal to the limit as h approaches 0 into f of x plus h minus f of x all over h. So that's the formula. So I'm going to work with this. Now for f of x plus h simply means for the function this, wherever we see x, so I'm going to put x plus h. So this is going to become the limit as h approaches 0. So in place of x, so we're going to put x plus h. So we're going to have x plus h all square minus our f of x is given as x squared plus 2. So I'm going to put this into a bracket. So now we're going to expand this. So by expanding this, we're going to have x squared plus 2xh plus h squared minus 2 times x squared. We're going to have minus x squared. 2 times plus 2, we're going to have minus 2 all into h. Okay, sorry, this is going to be all h. So we're going to continue by collecting like terms. And collecting like terms in this, we're going to have, okay, sorry, we made a mistake somewhere, so we're going to go back. So when in place of x squared we put this, we didn't add our plus 2, so adding plus 2 here. So we're going to add plus 2 here also. So we're going to continue by collecting like terms. So we're going to have the limit as h approaches 0. X squared minus x squared is going to give us 0. So we're going to have this left 2xh plus h squared. Plus 2 minus 2 is going to give us 0. So there's no need for us to write it. So we're just going to put minus x squared. Okay, sorry. We already cancelled out this. This is not going to pass of it. All over h. I'm so sorry for this. So at this point, we are going to divide all through by h. So dividing all through by h, you are going to have the limit as h approaches 0 to be 2x plus h. When h cancels, we are going to have this. When it cancels, we are going to have this. So putting 0 in place of h, we are going to have 2x plus 0, which is going to give us 2x. So here's another example under the first principle. We're going to take another example. Given a function f of x, which is equal to 3x squared minus 4x plus 7. So we're going to use our formula, and our formula is given as the f prime of x, which is equal to the limit as h approaches 0 into f of x plus h minus f of x all into h. Now, told you for we to get this, wherever we see x, we're going to put x plus h. So we're going to have something like this. The limit as h approaches 0, we're going to have, put into a bracket, we're going to have 3 into x plus h or square minus 4 into x plus h plus 7 minus our f of x is given as 3, put this into a bracket, 3x squared minus 4x plus 7. So having something like this all into h. So I'm going to expand this. So by expanding this, we're going to have something like this. The limit as h approaches 0. By expanding this, it's going to be in a bracket. So we're going to have x squared plus 2sh plus h squared into a bracket minus 4x minus times plus, we're going to have minus, so we have 4 times h, 4h plus 7. So opening this bracket, we're going to have minus times 3x, so we're going to have minus 3x squared, minus times minus, which is 4x plus 4x, minus times this is minus, so we have minus 7 all into h. So by opening this bracket, we're going to have the limit as h approaches 0. We're going to have 3s squared. 3 times this is going to give us 6xh. 3 times this is going to give us plus 3h squared minus 4x minus 4h plus 7 minus 3x squared plus 4x minus 7 all into h. So we're going to cancel out some things. So by cancelling out this and this is going to go out from here because 3 minus 3 is 0. Some things can also cancel out us, okay? Minus 4x plus 4 is going to give us 0, so this is going to go out also. Plus 7 minus 7 is going to give us 0, so this and this is going to go out also. So I'm just going to have the limit as h approaches 0. We're going to have 6xh plus 3h squared minus 4h. So this is what I'm going to have all into h. So we're going to divide all through by h. So we're going to have the limit as h approaches 0. So dividing all through by h is going to cancel this. We're going to have 6x. When this cancels, since this is carrying a square, we're going to have just one left. So it becomes plus 3h minus, when h cancels, we're just going to have 4 left. So wherever we see h, we're going to put 0. So we're going to have 6x plus 3 into 0 minus 4, which is going to give us 6x. 3 times 0 is 0. So no need for us to write, since 0 is going to equate to 0, so I'm just going to put a minus 4. So this is the answer when we use the first derivative of the first principle to solve for it. I really hope this video is helpful.